Hello everybody. Today we will be dealing with differential calculus. Now, the first thing we're going to start with is the remainder and factor theorem. So let's just start with the remainder theorem. I know the factor theorem is more easier to grasp, but it will be best to go over the remainder theorem for this one, okay? So for the remainder theorem, right, take note of the following. If f of x is a polynomial, right? So for example, obviously if we have x to the nth degree and where n is actually greater than, let's say, greater or equal to 1, but n is going to be, n is actually going to be an element of integers. Okay. So obviously that's when it's polynomials, when the x has a degree where it's 1, 2, 3, all the way to the highest possible number, nothing between, nothing less. So if f of x is a polynomial, then what we are going to consider is the following. Then ax plus b will be a root, right, such that we will say ax plus b is equal to 0, which implies to us that we are going to have what? We're going to solve for x, and we're going to say ax equals to negative b, and therefore we can say x is equal to, when we divide both sides by a, it will be negative b over a. So that indicates to us that what? So then, thus, our f of negative b over a, right, which is, remember, it's f of x, but because you solve for x, it's now negative b over a, is going to be equal to some remainder, but we say it's not equal to 0. Okay, so that must have probably scared you a little bit. But let me just go through this again, okay? Because I know I was just writing it down for you, but now let's actually understand what we're going to do, and when we do examples, you'll see it makes a lot of sense. So if f of x is a polynomial, so it's just like a parabola, a linear function, a cubic function, which we're going to go into later, anything like that, then ax plus b is a root, actually, so which means I should have added is a root, so I'll add that at the end of the video, is a root such that ax plus b equals 0, which implies to us obviously that x is equal to negative b over a when we solve for x. Thus f of negative b over a is not equal to 0. So that is the remainder theorem. Obviously a remainder means we have something remaining. If it wasn't a remainder, then it would be 0. That means we would have nothing that remains. So let's rather do examples to see, just to get used to it in this case over here. So let's start with the first example. Alright, so here's the first example. Use the remainder theorem, so RT, to find the remainder when f of x is equal to 4x cubed minus 8x squared plus x plus 2 is divided by x plus 4, which is number A, number B, x minus 2, and number C, 2x minus 5. So in our definition, when we said f of negative b over a is not equal to 0, what we are trying to say is we are going to let this, each and every one of these, be equal to 0 to find the root of the function and to plug that root into the function to see if we get 0 or some remainder value which is not 0, a non-zero value. So let's just do it one by one, and I'll explain it step by step in that case. So x plus 4, first things first, x plus 4 equals to 0 tells us that when we solve for x, x is equal to negative 4. So this is going to be our root that we are going to use, okay? In that case over here, if we are going to say f of x, so at x equals to negative 4, then this implies to us, or we can just say over here, f of negative 4, right, is going to be equal to what? We're replacing x with negative 4. So everywhere where we see x in the function, we'll replace with negative 4. So it's going to be 4 multiplied by negative 4 raised to the power of 3 minus 8 multiplied by negative 4 raised to the power of 2 plus negative 4 plus 2. And then what is that value going to be? If you put it on a calculator, we get the following. We will get negative 386. And what do you notice? This negative 386 is actually not equal to 0. So therefore, the answer would be the remainder. So we say therefore remainder is negative 386 at x equals to negative 4. So what do you notice? The question we are answering is we need to find the remainder. And the remainder is negative 386 at x equals negative 4, which is the root, or when we divide by x plus 4 for the function. This is just a method that we use. Let's do number b. Okay. See, that was all you had to do, by the way. So it's not that crazy. For number b, what you need to do is basically the same thing. What do we have? X minus 2. So you just let x minus 2 be equal to 0, right? So x minus 2 equals 0. This tells us that x is going to be equal to 2, positive 2, right? So therefore, we need to note that x equals 2 is actually the root of that function. So now we need to find the remainder. So we just need to plug that root in to the function. So at x equals to 2, then f of 2 is just equal to the function at x equals 2. So all we're going to do once again is just plug in 2. So it's going to be 4 into 2 raised to the power of 3 minus 8 into 2 raised to the power of 2 plus 2 plus 2. And what do we get as an answer? Our answer for this one will be 4. And what do you notice? 4 is not the same as 0. So therefore, we can say the remainder is 4 at x equals 2. And something you can also add at the end over here is say 4 f of x. So for the function, you're specifying for that specific function that the remainder is 4 at that point, x equals 2. It's basically the mathematics that you did. At x equals 2, the function is going to be equal to 4, which is not the same as 0. So there's basically your English reasoning. And let's do the last one. So number C, what is the root that we're working with? It's going to be 2x minus 5, right? So 2x minus 5 equals to 0 implies to us that we're going to have 2x equals to positive 5, and then divide both sides by 2, x is equal to 5 over 2. Therefore, we're working at x equals 5 over 2. And what are we going to do? At x equals 5 over 2, then what we're going to have is f of 5 over 2 is just equal to, basically we're going to plug it in again. So I'm just going to skip to that part. Alrighty, so when we plug in 5 over 2 for x, we notice we're going to have all of this, and we're going to have 17, which is not equal to 0. Do you notice that therefore, since it's not equal to 0, we can say that the remainder is going to be what? 17 at x equals to 5 over 2 for f of x. Okay, there we go. And there's our answers, right? It's not that bad. So let's do like a little bit of a tricky question, but we still use the same application that we usually do. Alright, so here we go. When g of x is equal to x cubed minus px squared plus x plus 1 is divided by x minus 3, the remainder is 4. Then we need to solve for p. So first things first, what are they telling us? They are telling us that we are dividing g of x, which is all of that, by x minus 3. Where what? What are we going to say here? The root x minus 3 implies, it's going to be, when it's equal to 0, it's going to imply to us that x is equal to 3. Okay, So that is our root that we are going to be working with, right? But also it says here, when it is divided by x minus 3, the remainder is 4. So what does that imply to us? This further implies to us that at x equals 3, meaning at f of 3, the whole answer is going to be 4. The remainder is going to be 4. So what does that actually tell us? That when we plug x equals 3 into the function, we get an answer of 4. But we would have never known that if they never told us, because we have a p. So all we're going to do is solve for p in this case. Okay. So therefore we know that f of 3 is just going to be equal to what? Oh, sorry, it's not really going to be f. It's actually going to be g, right? It's going to be g. I'm so used to the f. So yeah, crazy. So this implies to us now that 4 is going to be equal to, I guess I can plug this thing in over here, 3 to the power of 3 minus p multiplied by 3 to the power of 2 plus 3 plus 1 is equal to 4, right? That makes a lot of sense now, because it's basically the function at x equals 3 is equal to 4. So now we just simplify, right? So we get 3 to the power of 3, which is 27, minus p times 3 squared, which is just 9p. And then we're going to have plus 3 plus 4, 1, which is equal to positive 4, which is equal to 4. And notice we can just minus both sides by 4 and they cancel. And then what are we left with? We're left with 27 minus 9p is equal to 0. And then we solve for p. We can say here that if we take the 9p over, it's 27 equals to 9p. And we divide both sides by 9. Therefore, p is just equal to 27 over 9, which is just equal to 3. So therefore, p is just equal to 3. Was that difficult? It was not difficult at all. It's just the fact that when you learn something new for the first time, it seems hectic because you're reading all of this nonsense. But then you just try and apply it, and then you try and get used to it, it becomes so much easier. It's just getting into something becomes difficult, but then when you get used to it, you realize, damn, it's actually not that bad. So let's get into factor theorem now. Basically the same thing, but instead it's equal to 0. We'll see. Alright, so here we are. So we're going to say this again. If f of x, a function, is a polynomial, right, then, and ax, so ax plus b, which is a linear function obviously, is a factor, then we are going to say that if of negative b over a, remember where that negative b over a came from? It obviously came from the fact that we say ax plus b equals to 0 implies to us that x is equal to negative b over a, because you just solve for x, is then going to be equal to 0. This is the factor theorem, so it's equal to 0. And then obviously, in the case of f of negative b over a being equal to 0, then ax plus b is a factor, so which means this is our definition. So let's actually get straight to an example so you can see this in action. Alright, so here's a question. Given f of x is equal to x cubed minus 3x plus 2, find the remainder when f is divided by x plus 2 and x minus 1. Remainder? What are we doing with remainders? That's a good question. Now let's just solve this question as if we actually did a remainder question. That's why I put this in here, right? If we are given this function, find the remainder when f is divided by x plus 2 and x minus 1. So let's first work with x plus 2. So x plus 2 equals to 0 implies to us that x is equal to negative 2. And therefore at f of negative 2, right, at x equals negative 2, we have f of negative 2, which we just replace all the x values for the function with negative 2. Negative 2 cubed minus 3 into negative 2 plus 2. And then what is this going to be? Well, notice that we are just going to have, I'm just going to do it underneath each other. Negative 2 cubed is just equal to negative 8. and then negative 3 times negative 2 is just equal to positive 6 plus 2, and notice this is going to give us 0, right? So f of negative 2 is just going to be equal to 0. What does that tell us? Isn't this just a factor? Let's try x minus 1. So let's do that, right? With x minus 1 equals to 0, this implies to us that we are going to have x equals to 1. So let's say f of 1, right, is equal to, so at x equals 1, we'll have 1 cubed minus 3 into 1, not squared, plus 2. And this is just going to be what? 1 minus 3 plus 2, and notice this is just going to be 0. And that's also a factor. So what are we going to answer for this? It says find remainder. How are we going to answer this question? You say over here, therefore, since both x plus 2 and x minus 1 are factors of f of x, there is no remainder for those from those roots. Okay, so there we go. That's how you would answer this question, because you need to show that you know what you're doing. And I just noticed that literally everything else was showing up in the background, but it is what it is, I guess. But hopefully that makes a lot of sense. So that would be the factor and remainder theorem for this case over here. So I'm going to give you a question to try on your own and then see what you can answer from all of this. So your question you should try on your own is to determine the values of a and b if x squared plus x minus 2 is a factor of x cubed plus ax squared plus 2x plus b. All the best of this question.